the terminologies and concepts used in geometry. In this video, we are going to learn about defined terms, rays and opposite rays, the difference and illustration of curves and surfaces, and manifolds. Now that you've learned about the definition and types of curves and surfaces, let's proceed to the last part of our topic, which is manifolds. What is manifold? A manifold is a generalization and abstraction of the notion of a curved surface. A manifold is a topological space that is modeled closely on Euclidean space locally but may vary widely in global properties. To illustrate this idea, consider the ancient belief that the Earth was flat as contrasted with the modern evidence that it is round. The discrepancy arises essentially from the fact that the small scales that we see, the Earth does indeed look flat. In general, any object that is nearly flat on small scale is a manifold, and so manifold constitute a generalization of objects we could live on in which we would encounter the round or flat Earth problem as first codified by Poincaré. One of the goals of topology is to find ways of distinguishing manifolds. For instance, a circle is topologically the same as any closed loop no matter how different these two manifolds may appear. Similarly, the surface of a coffee mug with a handle is topologically the same as the surface of the donut, and this type of surface is called a torus. Manifolds have four classifications. The first classification is the one-dimensional manifold or 1D manifold. 1D manifold or one-dimensional manifold includes lines and circles but not lemniscates. In one-dimensional manifolds, the big idea is that we can also have open-ended curves that extend out to infinity, which are natural mappings to a one-dimensional line. Circles, parabolas, hyperbolas, and cubic curves are all 1D manifolds. The second classification is the two-dimensional manifolds or 2D manifolds. Two-dimensional manifolds are also called surfaces. Examples include the plane, the sphere, and the torus, and also the Klein bottle and the real projective plane. The simplest one is a sphere. You can imagine each infinitesimal patch of the sphere locally resembles a 2D Euclidean plane. Similarly, any 2D surface including a plane that doesn't self-intersect is also a 2D manifold. The following are the real-life examples of 2D manifolds. The third classification is the smooth manifold. Smooth manifolds, also called differentiable manifolds, are manifolds for which overlapping charts relate smoothly to each other, meaning that the inverse of one followed by the other is an infinitely differentiable map from Euclidean space to itself. A smooth manifold is a topological manifold together with its functional structure and so differs from a topological manifold because the notion of differentiability exists on it. Every smooth manifold is a topological manifold, but not necessarily vice versa. A topological manifold is a topological space which locally resembles real n-dimensional Euclidean space. Examples of smooth manifolds in real life are the following. The fourth classification of manifold is the Riemannian manifold. Riemannian manifolds are smooth manifolds equipped with a Riemannian metric that is defined as the shortest length from one point to another along the curve. The following image are the examples of Riemannian manifold. And that ends my discussion for the defined terms rays and opposite rays, curves and surfaces, and manifolds. I hope that you've learned something out of this video. Once again, I'm unique number 10, Iron Joy H. Fernandez. Thanks for watching and good holy.